All right, everyone, get ready for a deep dive. We're going deep into the world of suffix trees and prefix trees.
That's right.
If you're listening,
Yeah.
you want to know what makes these two data structures tick and what they're good for.
Exactly.
So we're going to break it all down.
Yeah.
Plus, we're going to uncover some surprising connections to things you use every day.
Right.
Like, did you know that autocomplete and spell checkers, they actually rely on these structures?
It's true.
It's pretty cool.
What's really fascinating about both of these structures, suffix trees and prefix trees, is that they solve a really fundamental problem in computer science.
Okay.
And that is how to efficiently store and search strings.
Okay.
So you see, when you compare strings character by character,
Yeah.
it's way more complex than comparing numbers.
Okay.
It's like, imagine trying to find a word in the dictionary by flipping through pages.
Right.
It's not as simple as finding a number on a number line.
Okay, so you're saying traditional binary trees aren't ideal for strings.
Exactly. With binary trees, you're stuck comparing entire strings,
Right.
which can be really time-consuming, especially when you're dealing with large data sets.
Yeah.
Tries offer a much more elegant solution.
Tries. Is that short for something?
It is a fun little name,
Yeah.
but it actually stands for retrieval.
Oh, okay.
Retrieval.
I see.
So a trie, also called a prefix tree,
Uh-huh.
stores strings in a way that makes prefix searching super efficient.
So is that how autocomplete works?
Precisely.
Okay.
Like when you're typing into Google and it starts suggesting search terms.
It's using a try.
It is.
Wow.
And it's not just Google.
Oh.
Tries power autocomplete on your phone, spell checkers, even IP routing.
Really?
Yeah, which is how your router figures out the best path for your internet traffic.
Wow, tries are working hard behind the scenes.
They are?
So how do they actually work?
Well, imagine a choose-your-own-adventure book, but for words.
Okay.
So each node in the trie represents a letter, and you follow branches to spell out words.
Oh.
So for example, if we have the words fail, false, tree, try, true, example, and exam,
Okay.
each node will represent a letter in those words.
Okay, so you start at the root and follow the branches, kind of like taking a path.
Exactly.
Yes,
So
yeah.
if you follow the F branch,
Mm.
you might split for A to get fail and false, and so on.
Okay.
And each node also indicates if it marks the end of a complete word.
Oh, I see.
Yeah.
So if I search for try, I'd
Mhm.
go from the root to T.
Yeah.
Then R, then E, and boom, there it is.
Exactly.
That's pretty clever.
It is. And the beauty of it is you can quickly see if a word exists just by traversing the trie.
Okay.
You can also easily find all words that share a common prefix, which is why they're perfect for autocomplete features.
So we just build these things letter by letter.
Well, there are a few different ways to actually implement a trie.
Okay.
You can use arrays, binary trees, or even hash tables.
Okay.
And each approach has its pros and cons in
Right.
terms of speed and memory usage.
Yeah, I bet arrays are probably the easiest to understand, but I can imagine they could get really huge if you're talking about a massive dictionary.
You're absolutely right.
Yeah.
Arrays are simple, but they can be memory hogs.
Yeah.
Trees offer a more balanced approach.
Okay.
And hash tables, well, they introduce a whole other set of complexities.
Right.
So really, the way you implement a trie, it depends on your specific needs.
Okay, so there's more than one way to build a try.
Right.
Makes sense.
Yeah.
But wait, you mentioned compressed tries earlier.
Yes.
What are those all about?
So compressed tries are all about efficiency.
Okay.
They take those basic tries and make them even more compact. So imagine you have a branch
Yeah.
with S, then H, then O,
Yeah.
each with only one child.
Okay.
A compressed trie would just merge those into one node labeled show.
So it's like zipping a file on your computer, less space, same information.
Exactly.
That's pretty neat.
It is.
So that brings us to, I think, a really important question. How do suffix trees differ from these prefix trees?
That's a great question.
Because that's what we're here for.
Yeah.
Suffix trees honestly sound way more intimidating.
Well,
What's the deal with those?
while prefix trees store prefixes,
Mm.
suffix trees store all possible suffixes of a text.
Why?
It's like taking a sentence and
Wow.
indexing every possible ending.
Hold on. Give me an example.
Sure.
Let's say we have the text banana.
Okay.
What would its suffix tree look like?
Great example.
Yeah.
So a suffix tree for banana would store banana,
Okay.
anana,
Okay.
anana, and even just I.
Okay.
Yeah. So it's breaking the text down into all its possible endings.
Wow, that seems like a lot of information.
It is.
Why would we want to do that?
It sounds crazy,
Yeah.
but it's incredibly useful.
Okay.
Trust me.
Right.
We'll get into why, but
Okay.
suffix trees have some really powerful applications,
Okay.
especially when you need to find patterns in a text quickly. So think about like DNA analysis, for example.
Okay, hold on. You're saying suffix trees are used for things like DNA sequencing?
Exactly.
I need to hear more about this.
We'll get there.
All right.
But first, let's take a closer look at how these suffix trees work their magic.
Okay.
So imagine you're trying to find a specific gene sequence
Okay.
within a massive DNA strand.
Mm-hmm.
A suffix tree lets you search for that sequence incredibly fast.
Okay, I'm starting to see why storing all those suffixes might be useful.
Yeah.
But how does that actually work in practice?
So each node in a suffix tree represents a substring of the text.
Okay.
And by traversing the branches,
Mm-hmm.
you can quickly locate any substring you're looking for.
Okay.
And because the tree contains all possible suffixes,
Yeah.
you're essentially searching the entire text simultaneously.
So it's like having a superpowered search engine,
Right.
but specifically designed for text patterns.
Exactly.
That's pretty mind-blowing.
And it's not just about finding exact matches. Suffix trees can also help you find the longest repeating substring within a text.
Wait, how does that work?
So think about the word Mississippi.
Okay.
The longest repeating substring is EC, right?
Right.
In a suffix tree, you'd find this by looking for the deepest internal node
Yeah.
that has multiple children.
Okay, and what's an internal node again?
Good question.
Yeah.
An internal node is any node in the tree that has at least one child.
Okay.
In this case, it represents a substring that is shared by multiple suffixes,
Okay.
like EC being a part of both Issippi and Ississippi.
That makes
Yeah.
sense.
Yeah,
So the deeper the internal node,
Right.
the longer the repeating substring it represents.
exactly.
I'm starting to see how these trees can reveal these hidden patterns within text.
Exactly, and that's just scratching the surface.
Oh, wow.
Suffix trees can also be used to compare two different texts
Okay.
and identify their longest common substring.
So like a turbocharged version of those like compared documents features in word processors.
Exactly. Imagine you're trying to track changes between two drafts of a book.
Right.
A suffix tree could pinpoint those changes in a flash,
Wow.
highlighting the shared substrings
Okay.
and revealing what's been added or deleted.
Okay, I'm convinced suffix trees are incredibly powerful tools.
They are.
But I have to admit, I'm still a bit fuzzy on how they're actually constructed.
Sure.
Is it as simple as taking all the suffixes of a text and just throwing them into a trie?
It's a bit more involved than that.
Okay.
There are some really clever algorithms
Okay.
designed to build suffix trees efficiently.
Okay.
One common approach is AmCan's algorithm,
Okay.
which constructs a suffix tree in linear time.
Linear time. You're starting to lose me again.
It means that the time it takes to build the tree
Okay.
is directly proportional to the length of the text.
Okay.
So a longer text takes a longer to process,
Right.
but the relationship is very predictable and efficient.
Okay. So there's some fancy math going on behind the scenes.
There is.
But the result is this suffix tree that lets us analyze text in all sorts of amazing ways.
Exactly. And remember, those applications extend far beyond just text analysis.
Right.
Suffix trees are used in bioinformatics
Right.
for tasks like DNA sequencing and genome analysis.
Okay.
They're also used in data compression algorithms
Mm-hmm.
to make files smaller, and even in plagiarism detection
Oh.
to identify copied text.
Oh, it's like they're the Swiss Army knife of data structures.
Right.
Versatile and ready to tackle a wide range of challenges.
And that versatility really comes from their unique ability to capture the relationships between the substrings
Okay.
within a text. It's like they provide a fingerprint of the text,
Okay.
unlocking hidden patterns and insights.
Okay, I think I'm starting to grasp the big picture here.
Good.
Prefix trees are great for searching
Yeah.
based on the beginning of a word,
Right.
like an autocomplete.
Mm-hmm.
Suffix trees, on the other hand, they excel at analyzing all the possible endings,
Yes.
which opens up this whole world of possibilities
Yeah.
for pattern matching and deeper text analysis.
You got it.
Okay.
And the choice between using a prefix tree or a suffix tree really depends on the specific task that you're trying to accomplish.
Okay.
Are you searching for a specific prefix,
Right.
or do you need to analyze all possible suffixes to find patterns?
So it's all about choosing the right tool for the job.
Exactly.
And in all the cases, it seems like suffix trees are kind of the more powerful option,
Yeah.
even if they're a bit more complex.
That's a fair assessment.
Yeah,
But, sometimes simplicity is key.
it's true.
If you only need to perform basic prefix searches.
Right.
A try might be the more efficient and straightforward solution.
That makes sense.
Yeah,
It's always about finding the right balance between complexity and efficiency.
absolutely.
Well, I have to say, this deep dive has been incredibly enlightening.
I'm glad to hear that.
I'm feeling a lot more confident about my understanding of these data structures and their applications.
Good.
But hold on, before we wrap things up,
Yeah.
I have one more burning question.
Okay.
We've talked a lot about the theoretical side of things,
Uh-huh.
but I'm curious about the practical applications.
Sure.
What are some real-world examples where these concepts are being used today?
That's a great question. So let's start with tries,
Yep.
which are widely used in those autocomplete systems we talked about earlier.
Right.
Every time you type a search query into Google or start typing a message on your phone,
Right.
tries are working behind the scenes to suggest possible completions.
So tries are saving me from typos and making me look like a spelling whiz.
Exactly.
I knew there was a reason I love autocomplete.
Tries are also essential for spell checkers,
Right.
helping us catch those pesky errors before we hit send.
Hmm?
And remember those IP routers?
Yeah.
They use tries to quickly direct internet traffic to the right destination.
Wow, I never realized tries were so ubiquitous.
They're everywhere.
What about suffix trees? Where are they making their mark?
Suffix trees are proving invaluable in fields like bioinformatics,
Okay.
where they're used for DNA sequencing and genome analysis.
Right.
They're also used in data compression algorithms
Okay.
to make files smaller and more manageable.
Okay.
And in the world of plagiarism detection, suffix trees are helping to identify instances of copied text.
So from searching the web to analyzing DNA, these data structures are truly shaping the world around us.
And their impact is only going to grow as we continue to generate more and more data.
Right.
Understanding these fundamental concepts is becoming increasingly important
Yeah.
for anyone who wants to delve deeper into the world of computer science and data analysis.
I completely agree. This has been an incredibly insightful journey,
I'm glad.
and I'm excited to see how these data structures continue to evolve and find new applications.
Me too.
But wait, there's one more thing.
Oh, what's that?
We can't forget about the music.
The music.
You mentioned earlier that suffix trees can be used for music analysis.
Ah,
Just dying to hear more about that.
that's a fascinating application
Yeah.
that often gets overlooked.
Okay.
So think about a musical score.
Yeah.
It's essentially a sequence of notes,
Right.
just like a text is a sequence of characters.
So we can treat a melody like a string of text and
Yeah.
apply the same principles.
Exactly.
Interesting.
By building a suffix tree from a musical score,
Okay.
we can identify repeating patterns,
Okay.
themes, and variations within a piece of music.
So a suffix tree could help us understand the structure of like a Bach fugue
Precisely.
or the recurring motifs in a Beethoven symphony.
It's a very powerful way to analyze the underlying structure and complexity of music.
That's incredible. I love how these seemingly abstract concepts can have such unexpected applications
Right.
in creative fields like music.
And that's what makes computer science so exciting.
Yeah.
It's all about finding creative ways to solve problems and
Mhm.
uncover hidden patterns
Yeah.
using elegant and efficient algorithms.
Well, I think we've officially reached the end of our deep dive.
I think so too.
We've gone from the basics of tries to the complexities of suffix trees
Yes.
and their myriad applications. It's been an incredible journey,
I couldn't agree more.
and I hope our listeners have enjoyed the ride as much as we have.
I'm sure they have.
Yeah.
And you know what's really cool about these structures is they really bridge the gap between abstract theory and real-world applications.
Yeah.
They embody that elegance of computer science, but at the same time, they power some of the technologies that we use every day.
Yeah, it's like they're the unsung heroes of the digital age,
Totally.
just quietly working behind the scenes to make our lives easier and more efficient.
Exactly. And, as we generate more and more data,
Right.
the importance of efficient data structures like tries and suffix trees, it's
Yeah.
only going to grow.
Yeah.
They're essential for making sense of this massive sea of information
Right.
and extracting meaningful insights.
It's almost like they're the lenses through which we can see patterns and connections within data that would otherwise remain hidden.
That's a beautiful analogy. They give us the tools to navigate the complexities of the digital world
Right.
and really unlock its hidden potential.
Well, I think we've covered just about everything there is to know about suffix trees and prefix trees,
I think so too.
from the basics to their advanced applications.
Yeah.
And I have to say, I'm thoroughly impressed.
As am I. It's always a pleasure to
Yeah.
dive into these fascinating data structures.
And for our listeners who have been with us on this whirlwind tour of information,
Yeah.
I applaud you.
Yeah.
We've explored a lot, but hopefully you've come away with a newfound appreciation for the power and elegance of prefix and suffix trees.
Absolutely. They may seem like abstract concepts at first,
Yeah.
but as we've seen, they have a profound impact on our digital lives.
Right.
From, typing a search query to the routing of your internet traffic,
Yeah.
these data structures are working tirelessly behind the scenes.
Yeah, it's amazing how something so seemingly complex can have such a significant impact on our everyday experiences.
Absolutely, and the best part is there's always more to learn. If you're feeling adventurous, I encourage you to explore some of the interactive visualizations of suffix trees that are available online.
Okay.
They can really help you grasp the concepts in a more visual and intuitive way.
That's a great suggestion.
Yeah.
And for those of you who are feeling particularly inspired, here's a challenge.
Okay.
Could you create your own visualization of a suffix tree for a simple sentence?
Ooh.
It's a great way to test your understanding
Yeah.
and see these concepts in action.
I love that challenge.
Yeah,
Who knows, maybe you'll discover something new along the way.
the possibilities are endless.
They are.
On that note, we'll bid you farewell until next time. Keep those brains buzzing and keep exploring the amazing world of computer science.